UniFi network has a beautiful dashboard, but I want to know how it works because of 4 different reasons. Reason number 1, sometimes, especially if you leave the dashboard running for a long time, this throughput display is very buggy. Let me show you an example. You can see now, yes, the chart is correctly reflecting the upload and the download speed here, but the problem is these two speeds themselves are wrong. So you can see the upload and download are even all the time. It doesn't make sense. Just to prove this is wrong, if I simply refresh the whole page, see, this is correctly reflecting my current download and upload pattern. So previous one was apparently wrong. Reason number 2 is more about the UI. These icons are too small. No matter what the window size is, they simply don't adapt. Reason number 3, I don't like their design choice, which is you have to move your cursor to the icon to see the details. What I prefer is on a UI, I don't need to move my mouse. I can see everything I want on the same screen. Reason number 4 is more about to understand what some of the display really means. For example, here it has most common devices. And here it has top clients. How these two are related. For another example, here for the most common devices, for each icon, there's a count. It seems it's aggregated result, but I don't see what's the logic, because in this example case, every icon has the count 1. So due to the 4 different reasons, I have this video. I will dig deeper to find out how it works. You can customize the widgets displayed on the dashboard. There are 1, 2, 3, 4, 5 different widgets. In this video, we are going to focus on this throughput, which is not part of the widget, and this most active widget, this most common devices widget. For other widgets, they are based on the same data source, so I won't go through them one by one. Let's start with this one, the throughput. From the URL, you can see I'm accessing my UDM Pro locally, and this is a browser. I have never refreshed the page, but this page is being updated continuously. To find out what's going on, how this data is being provided continuously from the UDM Pro, we need to go to the developer mode of the browser. So go to View, Developer, Developer Tools. This is just for Chrome browser. For other browsers, there are similar options. Now I can see the developer tool. To see this data, we need to go to Network tab. Just by the nature of this fast continuous data delivery, I assume it's done through the socket. So see here, you can do filtering about network. By default, it's all. Now I'm filtering on socket already. But we don't see anything here. Why is that? Because I launched developer tool after this page was already displayed. Because the socket is one-time thing. Once it's established, it will stay connected. So to see the very beginning of any socket, I need to relaunch the page. So I simply click on the refresh button. Okay, see, there are totally 5 sockets. The one we are really interested in is the very first one. The request URL is simply a GET, but see the protocol part is WSS. This is not the familiar HTTP. WSS means it's a WebSocket. In this Wikipedia article, it explains WebSocket. It provides a bi-directional communication channel over a single TCP connection. It is designed to work over HTTP port 443 and 80. This is exactly what we see here. See the URL is HTTPS. So the communication is done through port 443. However, this is not regular HTTPS. It's WebSocket. What we are seeing here is just the header. The real data is under messages. If I scroll to the end, you can see the continuous change. The data for this chart is among these data messages. As indicated on the diagram, if you want to filter on the messages to see the data which is only relevant to this chart, this is the filter you want to use, dashboard sync. Let me do it. In the filter box, dashboard sync. See, we see the scrolling continuous sync data. Now we know the data is through the WebSocket and it's dashboard sync data. However, there's one thing I need to point out, because without understanding that part, you will not really see this type of messages. Let me remove the filter and then scroll to the very beginning. See the first column? Only this particular message is different. It's sent from the browser to the gateway. All other messages, they are simply data. They were received by the browser, sent from the gateway. But this particular message is different. See, what's inside the message is a subscription. So which means by default, if you don't do anything, you only establish the WebSocket link, the system will automatically transfer everything, but just not this part of data. To receive the throughput data, you have to specifically send out a subscription. Then the system will send you this part of data. To validate my understanding about this WebSocket connection, I wrote this very simple Python script. First, I get the username password from the command line input. Then I will connect to the UDM Pro. Here I construct the URL for the WebSocket connection. Then I establish the WebSocket connection. And once the connection is open, it will execute this onOpen. See here, I will construct a subscription message so that we can receive the continuous throughput messages. Then I send the subscription. Once I send this one, the system will start sending me the throughput data. So I have this on message to output the received message. I will not output everything of the message. Instead, I will only get the RX and the TX, output them in the console. Super simple program just to make sure the whole process works. So in the left side, let me simply run it. The IP address is the UDM Pro. Username, test, password. As long as it receives a message, it will output. This only confirms we are receiving something, but we are not 100% sure it's really for our internet throughput. Let me do this. From my phone, let me do a speed test using this particular internet connection. Run test. You see the huge jump regarding RX because now I'm testing download, right? Okay, now it's upload. See, it's changed. Now the TX is jumping. Now everything goes back to normal. This simple test confirms, yes, I'm really seeing the real throughput data. I call it a success. Let's move on to other dashboard widgets. The next thing is about these 4 parts: top APs, top clients, top apps, and most common devices. If you go to the dashboard widgets to customize the display, you can see they are put in 2 different settings. And for the most active one, you can enable them individually. This may give you the illusion that the backend data come from different sources. But in fact, all of them come from the exact same data source, a REST API call. So let me show you. You can see now in the Chrome's developer tool, I have stopped recording. That's why here you don't see anything. Then let me start recording from the browser. Let me refresh the page. You can see a lot of activities are going on, right? Okay, it's done. In the filter, if I filter on API, you will have very limited entries left. The one we are looking for is here, the aggregated dashboard. And there's a parameter, it's called history seconds, equals to this big value. It is the seconds within a day. You may ask why the API requests data for a day. See the screen? By default, the display is about 1 day. So let's do a simple test. If I change the display to 1 hour, and let's see the new API call. Now the seconds is 1 hour. So this is how it works in backend. For this API call, you can see the URL. This is the endpoint. So it's calling the API in the UDM Pro. It's requesting the aggregated dashboard data. And it's a GET. If you check the payload, nothing. Because API call only has one parameter, which is already in the URL. So there's no payload. But if you check the response, it's a huge response. There are a lot of sections. So we will examine the structure later. Before that, let me try to reproduce the API call from my client machine in a terminal. Just to confirm, yes, this API call is the one we want. This API call does return the data for all the icons we are seeing on the screen. So in the left side terminal, let me run this. I will input username, password, get the result into two environment variables. Username, test, password. Now we have two variables. Now let me run this curl command. What I'm providing is the username password, which I input earlier. The real API URL is here. What I want to do is to log on. This is the result, status active. Now let me do the real API call to get the aggregated dashboard data. Super simple, right? The exact same URL we can see in the right side Google Chrome. Let me simply run it. You can see the return is a huge JSON. So to examine it properly, let me redirect it to a file. Let me use a graphical tool to open the JSON file. The first level structure of the JSON file is very clear. See this dashboard meta? It has a widgets section. It described what widgets data are included. See this part? The most active apps, APs, clients. Just from the name, you can already guess this is exactly for these three widgets. And the next block, most common client fingerprints. In fact, this is for the most common devices widget. Just the name already tells us a lot about what these so-called most common devices are really about. They are not really about devices or clients. They are about client fingerprints. Interesting. So then let's first examine this part. Most active three things. So if I scroll down, yes, I can find it here. Expand it. We can see a lot of data. For example, this one. This is for AP. See on the screen, we see two APs, right? This is one of the AP. The next one is another AP. The third one is not AP anymore because you can confirm from the UI, we only have two top APs. Then what's the next one? The next one is the top clients. My Pixel phone. Next one is not about clients. It's about application. Application is about this part. This is one of the application. See the next one, another application, another. So basically in this way, the system provides all the information for each individual icon, which we can see on the dashboard. You may ask, what's app at all? How the system can even tell which app I use. In fact, this app is about DPI, about traffic identification. If you go to UniFi Network Application, Settings, under Cybersecure, for identification, by default is device and traffic. So the traffic is related to the top apps. So the system will examine the packet sent out from your clients to determine what apps it may come from. Of course, there might be some false identification, but in general, it should work fine. Just some background about so-called top apps. Then go back to dashboard. The next question about the data we receive from JSON. See, it doesn't include description of each app. It only has an application ID and application category. You may wonder, what's this? What are these IDs? How we can get the text, the description for them? So let me show you how. In the left side terminal, I have SSH'd to the UDM Pro. Let me go to user share DPI folder, then go to TDTS. This is the DPI engine used by Ubiquiti. There's a file, it's called bwdpi.app.db. In fact, it's a pure text file. Let me show it. Here you can see the simple database. There are 3 number columns, then followed by the app name. Let me pick the first one as example. App ID 190, category 13. So let me search for 13, 190. We do find one. The application type is QUIC. So this is how the system internally determines what the app is. But in the JSON, we only get the keys. We have seen the apps, APs, and the clients, all 3 of them. Now let's continue to examine these most common devices. As we mentioned, it's in a totally different part. It's here under this most common client fingerprints. So let's see what's inside. See, it only has 5 objects, which are exactly the same as on the UI. For the first one, the count, the aggregation is 1. This is the fingerprint. In this video, I will not talk about the details of fingerprinting. If you are interested, watch my previous video regarding device identification. Here, just by the structure, we can already understand what the count is. The count is for all your devices that share the same fingerprint. Because this is my lab environment, I have very limited devices connected. That's why for each fingerprint, I only have count 1. But in a real-world environment, for example, you have employees, they use the same model of laptop. They will be grouped under one icon. And here you will see the count. That's what this most common devices mean. It is not the same thing as the top clients. It's more like an inventory. It shows you for this type of device how many you have. Of course, because it's most common, if you have many different fingerprints, it will only show the top end. So far, we have clear understanding about the REST API core. However, there's one more thing which is related to the top clients. See the UI? One of the clients, it keeps showing this thing. It's active, it's doing something. How the system can tell which icon should have this type of effect? Let's continue digging. Because this reflects the real-time information. Apparently, this effect cannot be achieved by using API core. Then, what's the technology the system can use? You may guess it right. Exactly, WebSocket. That's exactly the system can display this real-time throughput. In fact, this result is in the same WebSocket, which we already discussed. It's just in the same WebSocket, there are multiple types of messages. For the throughput, it's only one of the types. For this effect, the current active client is another message. Let me show you. If I go to the socket, remove filter. So this is the socket we are talking about. Go to messages. So you can see in the messages, there are different types. In the message filter, let me filter the messages with client sync. Now we see the continuous message regarding the current active client. After talking about the WebSocket and the REST API, you may realize behind the screen, there are a lot of things going on through API calls, through real-time WebSocket. It may tax your local machine and the network a lot. So that's why, if possible, the system should trim the messages and only send the absolutely needed ones to the dashboard. So let's see whether the system really does that. You can see now I don't have any icons. I only have the left side pane and this statistics. So if I go to dashboard widgets, if I want to customize the widgets, let's say I want to enable the most common devices. Before doing that, in the developer tool, let me enable recording. You can see now I have a filter on API. Then let me enable this one. See what happened? The system had 2 API calls. The first one, the API name is called dashboard. It's a post, meaning it's changing something. If we go to the payload, see what's being changed. It lists out the widgets. We can see for the most common client fingerprints, yes, it's enabled. But if you check this one, most active apps, APs clients, is disabled. It's exactly what we want. So this is just the setting part. Then what's really changed? Let's check this API call. So this is the regular API call to get the 1 day's historical data, right? If we check the response, it's the long JSON file we checked previously. However, see, now I don't have the most active things enabled. In the left side, in our old JSON file, you can see we had this data object, most active apps, APs, clients. If I try to search this in the right side, most recent JSON, I cannot find it. But if I try to search this one, most common client fingerprints, yes, I can see it. Why? Because we enabled this widget, the system should include the data for this widget. Just want to explain the JSON information and the WebSocket messages are trimmed based on the customizing of your dashboard. Based on my understanding of how the dashboard works, I worked on this custom Python app. So you can see it will display a bigger, taller throughput display. It doesn't have the issue I talked about in the beginning of the video. Then it has the top clients, top apps, and the top AP sections as well. The difference is everything is already displayed in each tile. I don't need to move my mouse cursor over it to see more information. And the icons are bigger, it's clearer. If I want, I can make it work in full screen. You can see everything is scaled up, including the icons. Then just to show you I'm not faking this throughput display on my cell phone, let me do a speed test. You can check the change in real time from the UniFi UI and my UI. So it works. That's it. This is the end of the video. Thanks for watching.